Welcome, space enthusiasts. Today, we're embarking on a cosmic journey to uncover the mysteries of the most common, yet most enigmatic stars in our universe. Brace yourselves, because we're about to reveal 10 surprising facts about the red dwarf stars. From their incredible longevity to their violent flares, these celestial bodies are full of surprises. They might be the smallest in the stellar family, but trust us, their stories are anything but small. So buckle up, sit back, and prepare to be amazed by the secrets these celestial underdogs hold. Stay tuned till the end, because each fact we uncover will take you deeper into the enigmatic world of these fascinating stars. Let the cosmic journey begin. Have you ever wondered what secrets the most common stars in our universe hold? Today, we're diving into the captivating world of red dwarf stars, the unsung heroes of our cosmos. These celestial underdogs are incredibly ubiquitous, making up an estimated 75% of all stars in our universe. Imagine that. 3 out of every 4 stars you see in the night sky are likely red dwarfs. Yet, despite their prevalence, they're not as conspicuous as their more luminous counterparts. You see, red dwarfs are the smallest stars in the stellar family. They're classified as M dwarfs under the spectral classification system, a system that categorizes stars based on their temperature and color. Red dwarfs are quite cool, with surface temperatures ranging from about 2,500 to 4,000 degrees Celsius. That's significantly cooler than our own sun, which sizzles at around 5,500 degrees Celsius. Their cooler temperatures lend them their distinct red hue, hence the name red dwarfs. But these cooler temperatures also mean they burn through their nuclear fuel at a much slower pace than larger, hotter stars. This makes red dwarfs the long livers of the cosmos, with lifetimes spanning from tens to hundreds of billions of years. But don't be fooled by their small size and cool demeanor. Red dwarf stars are anything but docile. They're known for their violent flares and stellar winds, which could have intriguing implications for any potential life on planets orbiting them. So, while they may not be the brightest bulbs in the box, red dwarfs are certainly among the most interesting. They're a testament to the fact that sometimes it's the unsung heroes, the overlooked and underestimated, that hold the most fascinating stories. Now, let's delve into the surprising facts about these fascinating celestial objects. Did you know red dwarf stars are like the Methuselahs of the cosmos? They are the most numerous stars in the universe, and they're also the longest living. These cosmic lanterns have lifespans that can stretch up to trillions of years. Yes, you heard it right, trillions. That's because red dwarfs burn their fuel, hydrogen, very slowly, at a leisurely pace. Imagine a fireplace that's left to burn gently over countless millennia. That's what a red dwarf does. It sips its hydrogen fuel like a fine wine, savoring each drop, and that's why it lasts so long. In contrast, our sun, a middle-aged yellow dwarf, is like a teenager in star terms. It's expected to burn out in a mere 5 billion years, a blink in the cosmic timescale. So while our sun will have long since faded, red dwarfs will still be glowing warmly, casting their red light across the universe. So, in terms of stardom, these red dwarfs are the true long livers. Could life exist in the orbit of a red dwarf star? Now that's a question that's been tickling the curiosity of astronomers and space enthusiasts alike for years. You see, every star has what we call a habitable zone. This is a Goldilocks region around a star where it's not too hot, not too cold, but just right for liquid water to exist on a planet's surface, a key ingredient for life as we know it. Red dwarf stars are intriguing in this respect. They're smaller and cooler than our sun, which means their habitable zone is much closer. Picture a cozy celestial hug, if you will. This proximity could allow planets in this zone to potentially harbor life, given the right conditions. But it's not all rosy. There are challenges to life as we understand it in such close quarters. For one, planets in a red dwarf's habitable zone would be tidally locked. That means one side of the planet would always face the star, bathing in perpetual daylight, while the other side would be shrouded in eternal night. This could create extreme temperature differences that might challenge the existence of life. Additionally, red dwarfs are known for their violent youth. They often emit powerful flares that could strip a nearby planet of its atmosphere, making it less than hospitable for life. However, it's important to remember that our understanding of life is based on a sample size of one Earth. Life elsewhere in the universe could be radically different, adapting to conditions we can't even imagine. So, while red dwarfs present unique challenges, they also offer unique possibilities. Scientists are actively seeking out planets in the habitable zones of red dwarfs using the latest telescopes and technology. With each passing day, we inch closer to answering the question that's been echoing through the cosmos. The idea of life around a red dwarf is not just a sci-fi fantasy, but a scientific possibility. So, keep your eyes on the stars, because our understanding of the universe is always expanding, and you never know what we might discover next. But here's a twist. These stars are not as calm as they might seem. Behind their subtle glow and seemingly tranquil existence, red dwarf stars are known for their violent and often unpredictable flare-ups. Imagine a cosmic firework display, only these pyrotechnics can have far-reaching effects. These flares erupt with a force that can dwarf the energy released in similar solar flares from our own sun. Now, picture an Earth-like planet orbiting this volatile star. A sudden flare could expose the planet to harmful radiation, stripping away its atmosphere and making the conditions unsuitable for life as we know it. The frequency of these flares adds another layer to the puzzle. While it's common for young red dwarfs to flare up, even older, typically more stable stars aren't immune to these violent outbursts. This inconsistency makes predicting these celestial events a challenging task for astronomers. So, living close to a red dwarf might be a bit of a celestial roller coaster ride. Despite being the most common stars, why are red dwarfs not visible to the naked eye? A question that indeed piques our curiosity. The answer lies in their intrinsic low brightness. Red dwarfs are small, cool stars producing less energy than their larger counterparts. This results in a dim glow that is challenging to observe from Earth without the aid of a telescope. Despite their abundance in the universe, these stars are like cosmic wallflowers, blending into the background of the night sky. Their light is simply outshone by the brighter, more energetic stars. In fact, Proxima Centauri, our closest stellar neighbor and a red dwarf, is invisible to the naked eye. This dimness doesn't make red dwarfs any less fascinating, though. Their low brightness is a testament to their longevity, burning steadily and slowly for billions of years. These stars might be common, but they sure know how to play hide-and-seek in the cosmos. What if we told you these stars are the tortoises of the stellar race? Yes, you heard it right. Red dwarf stars, unlike their larger counterparts, are incredibly slow when it comes to fusion. They burn their fuel at such a leisurely pace that it seems like they're in no hurry to finish the race. This slow fusion rate of red dwarf stars is a key factor behind their extraordinarily long lifespans. They live life in the slow lane, consuming their hydrogen fuel so gradually that they can keep shining for trillions of years. That's far longer than the current age of our universe, which is a mere 13.8 billion years. This slow and steady approach to existence means that red dwarfs are still in their youth, when stars like our Sun have long since exhausted their nuclear fuel and faded away. So it seems fitting to say, in the universe's race, red dwarfs are indeed the steady winners. Are red dwarf stars the go-to places for planet hunters? You bet they are. Let's delve into why these celestial bodies are the ideal targets for exoplanet research. Now, when we think about red dwarf stars, we're talking about a class of stars that are smaller and cooler than our Sun. But don't let their size fool you. These stars pack a punch when it comes to their planetary systems. The proximity of planets around red dwarf stars is a key reason why they're so appealing to planet hunters. These stars are surrounded by a bevy of planets in close orbits. Imagine a cosmic dance floor with the red dwarf star as the DJ and the planets dancing around in a tight circle. This close proximity means that the gravitational interactions between the star and its planets are more pronounced, making them easier to detect. Moreover, the sheer number of planets around red dwarf stars is staggering. In fact, it's estimated that around 75% of all known exoplanets are found orbiting these stars. That's a lot of potential new worlds to explore. But it's not just about quantity. The quality of these planets is equally enticing. Many of these planets fall within the habitable zone of their star, the area where conditions might be just right for life as we know it to exist. Then there's the fact that red dwarf stars are the most common type of star in the universe. More stars mean more opportunities to find planets. It's like a cosmic lottery, and with red dwarf stars, the odds are ever in our favor. So if you're a planet hunter, where would you look? The answer is clear. You'd target the red dwarf stars. They offer a wealth of opportunities to discover new worlds, to delve into the mysteries of the cosmos, and to perhaps, just perhaps, find a place where life might exist beyond our own blue planet. For planet hunters, these stars are like the treasure troves of the cosmos. What does the future hold for these abundant stars? A question that often pops up in the minds of astronomers and stargazers alike. The future of red dwarf stars, like all things in the universe, is dictated by the laws of physics and time. Red dwarfs, being the most common type of star in the universe, have lifetimes that stretch over trillions of years. They burn their fuel so slowly and efficiently that even after the sun has long fizzled out, red dwarfs will still be in their prime. But what happens when they eventually run out of fuel? Unlike larger stars, which end their lives in spectacular supernova explosions, red dwarfs go out with a whisper, not a bang. Once they've exhausted their hydrogen fuel, they begin to contract under the weight of their own gravity. This contraction generates heat, which allows them to continue shining for hundreds of billions of years. Eventually, these stars will cool and contract into what's known as a white dwarf. This process is incredibly slow, taking even longer than the star's main sequence lifetime. As a white dwarf, the star will no longer undergo nuclear fusion, instead radiating its residual heat into space. Gradually, over billions of years, it will cool and fade until it becomes a black dwarf, a hypothetical stellar remnant, the existence of which is yet to be confirmed by observation. Despite their eventual fade into obscurity, the future of red dwarfs is something to marvel at. They will be among the last remaining sources of light in the universe, long after other stars have died out. They will continue to be a home for potential exoplanets and a source of fascination for astronomers. Their long lifetimes and potential for habitable planets make them an intriguing subject for the study of cosmic evolution and the search for extraterrestrial life. Even in their twilight years, these stars continue to intrigue us. As we look to the skies, the future of red dwarf stars is a testament to the enduring allure of the cosmos. Is there a paradox surrounding these stars? You may wonder. Well, let's explore the Red Dwarf Paradox. This perplexing question is all about age. Red dwarf stars are known for their incredibly long lifespans, some even reaching trillions of years. Now that's a number that's hard to wrap our heads around. Here's where the paradox comes in. The universe itself is thought to be only about 13.8 billion years old. So how can we have stars that are older than the universe itself? Well, we don't. Yet. You see, no red dwarf has ever been observed to die because the universe simply hasn't been around long enough for them to exhaust their fuel. This means that every red dwarf star we see today has been burning since they first formed and will continue to do so for trillions of years into the future. Red dwarfs certainly give us plenty to ponder over. So, what have we learned about these fascinating celestial objects? We've delved deep into the cosmos, exploring the most common type of star in the universe, the red dwarf stars. These celestial bodies are a bundle of paradoxes, holding secrets of the cosmos within their dim, fiery cores. One of the most striking aspects of red dwarf stars is their impressive longevity. These stars can live for trillions of years, thanks to their slow and steady nuclear fusion. This incredible lifespan far exceeds the age of the universe itself, making red dwarfs the cosmic equivalent of the tortoise in the fable of the tortoise and the hare. We also touched on the concept of the habitable zone. Red dwarf stars, despite their cooler temperature and dim light, may host planets in the Goldilocks zone, where conditions could be just right for life as we know it. Yet, these potentially habitable worlds face a significant challenge: the violent flares of their parent stars. These flares could strip away a planet's atmosphere, making it less hospitable for life. We discussed the Dimness Dilemma, which makes these stars hard to spot despite their abundance. Yet their dimness also has a silver lining, as it makes them perfect candidates for the search for exoplanets, thus earning them the title of Planet Hunter's Paradise. We then looked into the future of red dwarf stars. As the universe ages, these stars will become even more prominent, outliving other types of stars and becoming the primary sources of light in a far future cosmos. Lastly, we pondered the Red Dwarf Paradox. Despite their abundance and potential for hosting life, we've yet to find clear evidence of extraterrestrial life around these stars. This raises questions about the conditions needed for life to form and thrive, and adds another layer of mystery to these fascinating celestial objects. Next time you gaze up at the night sky, remember, the most common stars out there are as enigmatic as they are abundant. Before we wrap up, we'd like to invite you to join us in this captivating journey of cosmic discovery. If you've learned something new from this video, or if the mysteries of the red dwarf stars have sparked your curiosity, we'd love to hear from you. Let's create a fusion of facts and opinions. Give this video a like if you've enjoyed our celestial exploration, and share your thoughts in the comments section. Remember, every question, every thought, every discussion point helps us all to learn and grow. Don't forget to subscribe to Fact Fusion for more content that will take you on a journey through the cosmos, and feel free to share this video with your friends and family. Let's make our community the Planet Hunter's Paradise. Stay tuned for more fascinating facts from the universe, and remember, the cosmos is not just above us, it's within us, and it's a journey we are all on together. Until next time, keep looking up.